All right, everybody. So today is going to be another one of those days where I'm going to be saying the same thing that you know already about exponentials, but I'm going to be speaking in logarithms. So it may seem like it's new stuff. It's not new stuff. It is exponentials, but I'm going to be more speaking in the language of logarithms this time around. Last time I bounced back and forth a lot. Today is going to be much more about I'm going to speak logarithms, and I'm probably going to stay speaking logarithms for the most part. So we're going to evaluate some logarithms, expand, combine. It's probably going to be a longer video. I'm going to be breaking this up into pieces, so sorry for in advance for the jump cuts. So one of the things that we talked about when we first started graphing some of these 2 sections ago was about what happens when you put the base into a logarithm and when you put 1 into a logarithm. I don't think I made it very clear in that video, but if you put the base into its own logarithm, so if you do log base b of b, you get 1. And if you do log base b of 1, you get 0 every time. And if you translate that real fast, you can say, okay, well, b to the 1, that's b. Duh. Same thing. B to the 1 is b. Log base b is 1. B to the 0, oh, that's 1. Anything to the 0 power is 1. So same thing with log base b of 1. If you put 1 into a logarithm, you get 0. So we can do all these real fast. If we take the natural log of 1, putting 1 in a logarithm, that thing is 0. Whoop. You're 0. Here's another one where where's some more that we put in 0? There, I'm sorry, we put in 1. There's one I put in 1, so that's 0. If you put in a base into a logarithm, so like this one, this is log base e of e. So that has to be 1. I'm putting the base into its own logarithm. Same thing right here. I'm putting the base into its own logarithm, so that is 1. Here's another one where I did the no thing, where I put the 10 there. I shouldn't have done that. So that is also 1. Now you can do some sneaky stuff with this, and you can do those things in reverse. Look, here's that base, log base 10, and it's being used as an exponent. So in some sense, those two cancel each other out, but really they undo each other, and we're left with just what's in the logarithm, that x plus 8, similar to what happened right here. You can do the same thing here where you put those things into each other. So log base b of b, it would just be 1, but there's a goofy exponent in there. So what we keep is actually the exponent, x squared. This one is going to be, down here is going to behave just like what's going on up here. We're putting the base, log base exponent, the log with the same base into an exponent with that base. These bases match. So we're left with what's just inside the logarithm, 2x plus 5. Here's another one where we're putting the base of the logarithm into itself, log base b of b, but it's got an exponent. So the thing we're going to keep is that exponent, x plus 3. There's a particular property we're going to see a little bit later. That'll hopefully make some of those a little more clear. Now, one thing that you can do to expand logarithms, so you can take logarithms and you can break them up if you want to break them up into pieces and look at those little pieces, or if those pieces look gross, we just smash them all together into one big logarithm. Mathematicians like that, being able to break pieces up and put things back together. So that's this property. This is our power rule and our quotient rule for exponents. If you multiply 2 bases together, then you add the exponents, and logarithms are exponents. If you've got something over something and you've got matching bases, so dividing, you subtract the exponents. Logarithms are the exponents, and we're just subtracting them. So this is our product rule and our quotient rule. I think I said power rule earlier. So if I've got this log, I could separate it out into 2 separate logarithms. Could do log base b of f plus log base b of g, if that makes it easier for me to work with. Maybe I know stuff about log base b of f, but I don't know stuff about log base b of g. So I could separate them out and deal with them individually. This one, we've got some things being added together. So we've got a log of a plus a log of b. But then see that c that's down in the bottom? Well, hey, we just want to do this thing. We want to subtract it off. So we want to subtract log of c. Another way you can think about this one when we're looking at this one is imagine what you do with exponents. Where do positive exponents go? They go in the numerator. 10 times 5. Where do negative exponents go? They go in the denominator. I don't know why I wrote 2. They go in the denominator. Negative exponents go in the denominator. Positive exponents go up top. Negative exponents go on the bottom. Positive logarithms up top. Negative logarithms on the bottom. Notice that I only wrote one log. It's not going to be log over log. A common error on this one is people will write log bm over log bn. That is a common error. If you want to write that and cross this out neatly in your notes, note that it is not that. That is big no-nos. I can simplify this one actually a little bit. We get ln of 50 over 2, which is the ln of 25. That's a cursive L. Sometimes I write my natural logs with cursive L's, and I don't know why. I can't stop it. Here are two logarithms being added together, so we can write them as one single log being multiplied together. 7 times 3. So that's the log of 21. Neat. You can break them up. We can put them together. So expand is the tan ones, and then the blue and the red is where we're combining our logarithms. Depending upon what we're doing, like solving, sometimes we want them broken up, and sometimes we want to put them together. Okay, so one more exponent rule, and I'm not even going to have a separate thing for this, is the idea that if you have an exponent inside of a logarithm, and I was kind of using this earlier, but you can bring that exponent in front. So this was kind of that secret thing that I mentioned earlier. If you have an exponent inside of a logarithm, you can bring it in front of the logarithm. So you get k log base b of m. Now, I like to call this kind of like the log cabin problems, and you want to kind of give everybody a nice log cabin to hang out together in. So right now we've got two logarithms, but right out in front of the logarithms, we've got this 2 and the 3, and they're all cold outside. So before we put those in, we want to hurry up and make sure everybody's at least inside first. So I imagine like, okay, come on inside, come on inside. So the 2 comes inside and becomes an exponent, according to this rule up here. And then the 3 comes inside the other one. Now they're like, oh, well, we both have a log cabin. Wouldn't it be nice if we just shared a cabin together? Yeah, let's put everybody inside of a single logarithm. That's what we're trying to do, is write it as one logarithm. Now remember, if they're positive, they get to go upstairs. If they're negative, they're going to go downstairs. So notice that that second one was negative, so it goes to the denominator. The 10 squared, which was positive, we had a positive in front of it, it goes up top. Now we could kind of clean this up a little bit. We could make this log of 100 over 125. And then we can divide both of those by 5, so we get the log of 20 over, no. We can divide those both by 5. We can divide those both by 25, excuse me. We can divide those both by 25, so we get 4/5. Oof. And that's kind of why we like it. We couldn't do anything with this, but oh, look at how much neater that is now. Oh, that's great. Now this one, once again, we want to try to get everybody inside. First, those numbers in front. Oh my gosh, they're so cold. Get them nice inside the nice warm cabins. Come on inside. But once you come inside, you're going to be an exponent, okay? Oh. So everybody comes inside. I'm leaving the pluses and minuses in front, and apparently I left that 3 in front too. because I prefer to deal with them later. You could technically bring them in there, but it makes your life a little more difficult. So I don't want to make your lives difficult. So everybody's inside. Everybody is exponents now. So now we're going to bring them all into one big mega log cabin. Anybody who's positive, you get to go upstairs. A to the fifth has got a positive in front of it, so it goes upstairs. C to the third also has a positive in front of it, so it gets to go upstairs. Ugh, but look at this negative Nelly. B squared apparently didn't want to have a big log cabin together. It's got a negative in front of it, so the B squared needs to go into the denominator. D to the 7 also had a negative in front of its logarithm, so it's going to go hang out with those. Maybe those two will be a bit more cheery in the basement together. So there it is written as a single logarithm. All right, let's try a few more. Same idea. We want to try, but we're going to do this in reverse now. We want to try to expand it as much as possible. We're going to undo all the things that we did before. So in this first one, I've got two things being multiplied together. I've got that x to the 4, and I've got the cubed root of y. So I'm going to write those as two separate logarithms. Log base b of x to the 4 and log base b of the cubed root of y. Since they were being multiplied together inside of that logarithm, I'm going to add those two things together. Next, I'm going to bring my exponents in front, just to try to simplify what's going on inside of the logarithm. If I can keep that simple, it's going to make my logarithm thinking a lot easier. So that 4 comes in front. And that cubed root, you might say, oh, that can't come in front. It's not an exponent. It is. Cubed root is a 1/3 exponent. So let's bring that 1/3 in front. So all we have left inside of that logarithm is a y. Nice. That is fully expanded. Let's try the other one. So here I've got two things being subtracted. Once again, I'm going to break it into two logarithms. I've got my numerator, and I've got my denominator. I'm kind of in the way. All right. Numerator and denominator, and since they are being divided, I need to subtract them. Just like you would with exponents. You would subtract the exponents if they're being divided. Now I also want to bring those numbers into the front, the exponents, so that 4 is going to come in front of my logarithm. So log base a of 4 minus 5 log b. I think I said log base a. I meant to just say log a. Now this one, I have 4 different things going on. I have an x, I have a 4th root of d, we've got a y squared, and I've got I'm running out of colors, a square root of c. So each one of those is going to get its own natural log. So we've got the ln of x. And then we've got the 4th root of d. That also gets an ln. Since d was in the numerator, it's going to get a positive, just like I kept a positive in front of that ln of x. When we get that y squared, it also gets an ln, like everybody else, but y squared was in the denominator. It was being a bit of a negative Nelly. So we're going to give it a negative in front of there. Square root of c was also in the denominator. So it's a negative Nathan, so we're going to give that a negative as well. Now we want to bring all of our exponents in front. I'm just going to do this all in the same color. So we get ln of x plus that 4th root is a 1/4 exponent that we can pull in front of the natural log. So let's do it. Minus 2 ln of y minus that square root is a 1/2 exponent. So let's pull it in front. So all we have left in the inside is a c. So we fully expanded that thing, and we could also push it back together to return it back to our original format. We're not changing its value, we're changing how it looks to hopefully make our problem working a little simpler.